Hey, welcome back everyone. Today we're going to continue working on the 2D dynamic programming questions from the LeetCode roadmap. So in previous videos, I've covered the first 8 questions here that are in check marks, and today we're going to finish off the last 3. So starting off with the first one, which is edit distance. So in edit distance, we're given 2 different strings, word1 and word2, and we want to return the minimum number of operations required to convert word1 to word2. So here we have 3 different operations that we can do. We can either insert a character, we can delete a character, and we can replace a character. We can do these operations on either of the 2 strings until these 2 strings are the same. So taking a look at the example here, in example 1, we have word 1 is horse, H-O-R-S-E, and word 2 is R-O-S. So the output is 3, which represents that we have to do a minimum of 3 different operations, 3 of these operations, to change from horse to R-O-S. So first of all, let's start from the front of both words. So notice that H and R, these are different. So an optimal operation is that we can replace the character H with the character R. So now let's write a comment here. We have R-O-R-S-E. Now after that, we have the character O. There's O on both strings, so we're able to keep this O. So after that, we have R and S. Notice that we can remove this R, so we can take advantage of the S in word 1 to match it with the S in word 2. So the second operation we'll do is remove this R right here. So we have rose, R-O-S-E. And after that, because our word 2 is R-O-S, which is 1 less character than rose, we can just remove this E. So that's the third operation. And after 3 operations, we're able to make these 2 words the exact same. So looking at example 2 here, from intention to execution, we can first of all remove the T in intention, then replace the I with an E, replace N with X, so on and so forth until we get execution. So in both of these examples, we're changing from word 1 to word 2. So like a lot of 2D DP string questions, we have 2 strings here, word 1 and word 2. So we can use a 2D matrix to represent these 2 strings and how many changes we've done on them. So usually we'll have word 1 be the number of rows and word 2 be the number of columns in this 2D DP matrix. So let's create the dimensions for our matrix, which are m and n, and these are going to be equal to the lengths of these words. So word 1, word 2. So if you've done interleaving string, this is a very similar idea. And we can use a DP matrix to store how many changes we need to do to go from the ith character, or from the start to the ith character in word 1, and from the start to the jth character in word 2. So that's what dpij is going to represent. So let's create our matrix here, dpij. First of all, it's going to be 0 for everything in range n plus 1. The reason we're doing n plus 1, which is 1 greater than the length of word 2, is that we also want to think about the 0th character. So no characters from either word. That means we should also do for nothing in range n plus 1, since we should also consider the 0th character, or no characters at all, from the first word. So now we have our DP matrix. Let's actually tab this so it's indented correctly. Now we want to look at the base case for both words. So looking at the base case where we don't use any characters from word 2, meaning we use all the characters from word 1, that means we need to remove every character in word 1 to make up an empty string. So we can do a for loop to iterate through that. So for I in range n plus 1, dpi 0. I0 represents we use 0 characters from word 2 and I characters from word 1, where I could be 0 as well. And this is going to equal to I because we have to remove that character. So if we use 3 characters from word 1, that means we have to remove all 3 characters from word 1 to make up the empty string. That's why dpi0 is always equal to I. So how many characters we use, we need to remove all of those. So similarly, if we use no characters from word 1, then we have to remove all the characters from word 2. So for j in range n plus 1, dp0j, meaning we use 0 characters from word 1, j characters from word 2, this is going to equal to j. Because the same idea, we have to remove all j characters to make up the empty string. So after that, we can use a double for loop or a nested for loop to look through every other character that are not the 0th characters. So for I in range n plus 1, starting from 1 all the way to n plus 1, and for j in range starting from 1 to n plus 1, since we dealt with the 0th case already. So now we should look at two different cases. It's possible that the character exactly matches. For example, this O in word 1 matches with the O in word 2. So that's perfect. We don't need to do any operation. So if word I minus 1, remember I have to do I minus 1 because I is 1 index, whereas word is 0 indexed. So we have to change that. Equals to, I forgot word 1, word 2, j minus 1, same idea, to make the 1 index into a 0 indexed. So if this is the case, the character, for example, the O is equal in word 1 and word 2, then we don't have to do any operation. So dpij is equal to dp I minus 1, meaning before we included the character, dp and j minus 1. So before including the character in word 2, which is j minus 1, before including this character in word 1, which is I minus 1. So we don't have to increase this by 1, and dp represents the number of operations to get to ij. So let's say dpij, this is equivalent to the number of operations to get to the ith character in word 1 and jth character in word 2. So this is the nice case where the characters are the same. So otherwise, if these characters are not the same, then we have these three operations that we can do, right? So it's possible that we can insert a character, delete a character, or replace a character. So suppose we change the character. So if we change this character, then we can assume we can change the character in word 1 to the character in word 2. So for example, if this O and this O are not the same, if this is an A, for example, then we have to change the first character to an A. So change, we need to take a look at how many prior, so the number of ways prior to this change, which is dp I minus 1, j minus 1, plus 1 representing the operation of change that we're doing right here. So alternatively, we can also remove the character in the first word, so remove. This is going to equal to dp I minus 1, and j. So we're still keeping j, the index of word 2, however, we're just completely getting rid of this character in word 1, which is why we're taking a look at dp I minus 1, which is how many operations it took to get to the I minus 1th character, since we're removing the ith character completely. And we can keep j since we're not doing anything to word 2, plus 1. Plus 1 representing this operation of remove that we're doing here. So finally, we also have the option of add, which means we add a character that matches with word 2 into word 1. So this is equal to dp I. We can keep I the same since we're not changing I, but we do have to do j minus 1. And what j minus 1 represents is that we're essentially adding a character in word 1 is the same as removing a character in word 2 to make them the same. And plus 1 because this is one more operation that we have to do. So we have these three different options here, change, remove, add. We want to know which is the minimum number of operations we have to do in total, since the question wants the minimum. So dp ij, this is going to be the minimum of these three options, which are change, remove, and add. So after that, after this nested for loop, we're going to have a completed dp array or matrix, and this matrix on the bottom right corner, which is going to be dp m and n, this is going to be our answer, which is the number of operations we have to do to change the entirety of word 1 into word 2. So let's try running this. Cool, that's accepted. And just to make sure we're doing everything correctly, let's actually print every row in dp. So for row in dp, let's print row to see what they look like. Cool. So this 0 right here representing taking 0 characters from word 1 and 0 characters from word 2. So that of course takes 0 operations since they're both the empty string. So for every character in word 1 or in word 2 that we take, to get the empty string or the 0th character in word 1, we have to remove all of them. So for every character we take, we have to remove that, so that's that many operations, which is 1, 2, and 3. So same with this, 1, 2, 3, 4, 5, meaning if we take 5 characters from word 1, 0 characters from word 2, then we have to remove all 5, and so on and so forth. So then we have these different ones in the middle. For example, this one here, this represents if we take one character from word 1 and one character from word 2, then the optimal way for us to do that is to change this character. So changing the H to an R, that's going to be one operation. So this is a 1 right here. So after that, we have an O and another O. So at 2 in this matrix, this is going to be one operation as well, which is changing H to an R, since we can leave O by itself. And then as we introduce more characters, we're going to go down this matrix until we get our answer, which is going to be in the bottom right corner. So let's comment this out and let's submit it. Whoops. Cool, that worked. So let's move on to the next question. Burst balloons. So in burst balloons, we're given n balloons. These balloons are indexed from 0 all the way to n-1. So in each balloon is also painted with a number on it, which represented by an array nums, and we're asked to burst all of the balloons. So when we burst the ith balloon, we get a score, or coins, based on the value of nums I times the previous value times the value after it. Or if it goes out of bounds, then we just assume multiply by 1. So this is a little bit complicated, so let's actually look at the example here. In example 1, we have nums, which is 3, 1, 5, and 8. So right away in nums, we can choose any of these indices to burst. So for example, if we burst the 1 here, then we're going to multiply the previous number by itself times the number after. So 3 times 1 times 5, and that's how many coins we get. And then we lose the balloon here. So the array is going to be 3, 5, 8. So in the explanation here, we have 3, 1, 5, 8. And the coins we get, it's going to be the previous number times 1 times 5, which is 15. So we lost the 1th balloon. So now we have 3, 5, 8. If we pop the balloon in the middle, the 5 here, we get the previous number times current number times the number after, which is going to be 3 times 5 times 8, which is going to be 120. So then we have 3 and 8. After we pop the 5, we lost the 5, so we have 3 and 8. We can pop the balloon 3 here or the balloon 8. If we pop the balloon 3, we get nothing, which is going to be assumed to be 1, times 3 times 8, which is going to be 24. Finally, we're left with 8, which is going to be 1 times 8 times 1. So adding everything up, we get 167. So this is our optimal score. If we do a different ordering of poppings, then we're going to get a score lower than 167. And we want to return the optimal score here. So looking at example 2 here, we have two different numbers. So there's only two different ways we can pop. If we pop the 1 first, we get 1 times 5, which is 5. And then we have another 5. So we pop that 5 to get 10. But alternatively, if we pop the 5 first, then the 5 is gone. We just have 1. So we're going to get 5 plus 1, which is going to be 6. 6 is less than 10, so we want to get the maximum number of coins, which is going to be 10. So this question is probably going to be a range-based 2D DP question, where we look at different ranges in nums, and we're going to essentially store the maximum value. For example, we can split example 1 into two different ranges. So one range from 0 to 1 represented the 3 here, or another range including the 5 and the 8. So, and then we want to compute the maximum value we can get from these two different ranges separately, store them or memorize them in a DP matrix, or we can use a dictionary in this case, and then also calculate the value of using the 1 here in the end and adding everything up. However, the tricky part of this question is that if we remove the 1, then our two ranges actually collide. So if we remove the 1, then the range becomes 3, 5, and 8. So we're no longer able to deal with the two different ranges, 5 and 8 and 3 separately, because these two ranges are going to merge into one big range. So to deal with that, because we can choose the order of the popping of the balloons, we can alternatively say, what if we pop the 1 last? So if we pop the number 1 last, that means these two ranges, the range on the left and the range on the right, these two ranges are never going to collide. Since we're going to finish popping everything on the left, everything on the right and everything on the left first, and then we're going to pop the 1 after. So if we pop the 1 last, then we're never going to get the left range and the right range to collide. That means we can memorize results of the left range and the right range, and then get how much we get from the popping the 1 here, and adding those up to get our answer. So first of all, let's create n. N is going to be the len of nums. And we should also create a DP dictionary for us to memorize our results so we don't do the same operation more than once. So DP equals to a dictionary. And then for these types of questions, we can use a DFS function. So def DFS, and what this takes in is the left and the right indices of the range. So what we pass in is L and R. So first of all, if this range is invalid, or if L is greater than R, we should just return 0. Alternatively, if we've seen this range before, so if L comma R, this tuple is in DP, we should just return that. So return DP of the tuple, which is L and R. So finally, we can try every possible index inside this range from L to R and say, what if we remove that index last? So if we remove that index last, then we can divide this range into smaller ranges and compute those as well. So let's say for I in range starting from L all the way to R plus 1, since this is non-inclusive, we need to do R plus 1. So let's say we remove index I last. So let's write a comment. So remove index I last. So if we remove index I last, then we can calculate the previous value and the value after, as well as nums I, to get the number of coins from removing this index. So previous equals to nums L minus 1. Next equals to, let's call it after, since next is a keyword. So after equals to nums R plus 1. So we should also be careful of going out of range or out of scope. So we should also check if L is greater, L minus 1 is greater than equal to 0. Otherwise, we can just use 1, since the question says we'll use 1 when we go out of range. So we can only do R plus 1 if R plus 1 is less than n. Otherwise, we should do 1 as well. So how much value do we actually get? Well, we get our value, which is equal to previous times nums at I times the value after, which is after. So now we need to calculate the value of the two different ranges that we just subdivided. So the first range is going to be from left all the way to I minus 1. So that's the left range. And left range is going to be, it's going to make a new variable. So left equals to DFS all the way from L all the way to I minus 1. The right range is going to be DFS from I plus 1 all the way to R. So what we get is we get the value of popping this balloon here, as well as the value of the left range, plus the value of the right range. So we're not sure which value is best. We don't know which index we want to remove last. So we have to use a value max, and max should equal to the maximum of itself versus value. So we're going to set max to be the maximum of the values. Let's declare that. So mx initialized to 0. If we get a value that's better than 0, then mx is going to be set to that. So remember, we should memorize our answer so we don't do the same left and right range more than once. So dp, the tuple L and R, this should be memorized to be equal to mx, and we should return that. So return mx. Now, how should we call this function DFS? Well, we can call it on the entire scope of nums. So we should basically run the DFS from the first element all the way to the last element. So we can try returning DFS starting from 0 all the way to n minus 1. So let's try running this. Cool, that worked. So let's submit it. Cool, that worked. It took quite a while though. So this question is probably on the harder end of these range-based memorization questions, since the tricky part to this question is that instead of popping the balloon first, we actually have to pop the balloon last to guarantee that the left range and the right range are never combined into one. So if we can make sure that these two ranges are never intersecting with each other, they're never multiplying, for example, the 3 and 5 are never multiplying together, then that means we can safely remove this one last, and then we can repeat the process on the left and right ranges for this question. So definitely one of the harder DP questions, but we can still use a memoization result and just invert our thinking to keep the ranges separate. So moving on to the next question. regular expression matching. So in regular expression matching, we're given a string S and a pattern P. So we want to implement regular expression matching with support for dots and stars, or periods and wildcards. So essentially, the period can match any single character, while the wildcard can match 0 or more of the preceding element. And the matching should cover the entire input string and not part of it. So that's a little bit confusing, so let's look at the examples here. So first of all, in example 1, we're given S is AA and P is A. So P is a pattern, S is our goal. Notice that we can't make two A's from a pattern of one A. So this is not going to work, in which case we want to return false. So in example 2 here, S is AA while P is A star, or a wildcard. So wildcard means that we can use 0 or more of the preceding element. The preceding element is going to be the A. So we can use 0 or more A's to match our string S. So in this case, we want to use two A's, which is going to match exactly to S, and in that case, we want to return true. So in example 3 here, we have S equals to AB and P equals to period star. So period star can just match anything, since this period can match any character, and the star wildcard uses the period 0 or more times. So notice that this period star could match two different characters. So first, this period could be representing a B, and then after that, it could represent the A. So this pattern is just going to be able to match everything, in which case we want to return true as well. So in this question, again, we have two strings and we want to change one string basically into another. But a key point in this question is that looking at string P, whenever we have the wildcard character, what we care about is the character in front of it. So we should go backwards from the right to the left in P. If we go the other direction, for example, if we go from left to right and we see the character A, we have to check one more thing. We have to check whether or not it's a wildcard character or just strictly the character A. So that's a little bit more annoying. So it's easier for us to go from the right to the left, because whenever we see a wildcard character here, we're guaranteed to be able to see a character that we can use before the wildcard. This question says that it's guaranteed that for each appearance of the wildcard, there's going to be a previous valid character to match. So whenever we see a wildcard, we should just look at the character in front of it to see which character we can use 0 or more times. Cool, so hopefully that made sense. And like any 2D DP string questions, we can use M and N to represent the lengths of these strings. So M and N are going to be the lengths of S and the length of P. So after that, we can do a search starting from the end of these two strings. So let's say we have a function called DFS. Let's define it, def DFS, and it's going to take two different indices, I for the index which in string 1 or S, and J which is the index of string 2 or P. So whenever we have IJ, then we want to look for a match for all the characters from 0 all the way up to I, and all the characters in P from 0 all the way up to J. So first of all, we should create some base cases. So for example, if I is less than 0, meaning there's no more characters in S, and J is less than 0, meaning there's no more characters in P, that means we have the empty string in both cases. So we want to return true, since that's a perfect match. So alternatively, if J is less than 0, meaning there's no more characters in P, but there's still characters in S, so I is greater than or equal to 0, then we want to return false. Since our pattern here, we used it all up, but in S, there's still characters. So we can't match characters without a pattern, in which case we want to return false. So we should also memorize our results so we don't search the same I and J pair more than once. So let's create a TP, and this is going to be a dictionary. Cool. So after that, we can look at different patterns and different indices of S and P to match. So while there's still characters in, so if I is less than 0, so there's no more characters in S, but there's still characters in P, so and J is greater than or equal to 0. This is not necessarily a failure, because it's possible we have a wildcard character in P, in which case we can just use 0 instances of that to match up with the empty string. So in this case, we don't want to fail immediately. Instead, what we want to do is we should check if pj is equal to the wildcard character. So if it's equal to a wildcard, then there's still a chance this matching is valid. So we should memorize that as dpij is going to be equal to the wildcard character. So for example, if s is empty, this is nothing, and we see p is a and the wildcard character. So we should remove the wildcard character as well as the character previous to it, and basically cast p into an empty string. Basically use the character a 0 times. So in which case we want to skip the current character as well as the character previous to it. So we can get rid of 2 characters at a time. So it's going to be dpij minus 2 to remove the wildcard character as well as the character in front of it. Because when we have an empty string, we just want to use 0 instances of whatever character we get. That's why we have this, and we want to return dpij. This is memoizing it, and this is returning our answer. So alternatively, else, if p of j is not a wildcard character, so we have a solid character in p, but I is less than 0, in which case there's no characters left in s. In that case, we want to return false. So dp, let's memorize it, dpij is equal to false, and return false. Cool, so these are all the cases where we have no more characters left. So these are the 3 base cases. Now we can look at cases where I and j are both not less than 0. So first we should try to see if we memorize our result before. So if ij in dp, we could just return dpij. So now we have a lot of different options here. First of all, it's possible our character here in S is the same as the character here in P. So for example, here, they're both A's. So again, we're starting from the back. So the last A is the same as this A here in P. So if Si equals to Pj, then we don't have to do anything. We just consume the character in P. So, or alternatively, the character in P is a dot. In that case, we also want to consume that character in P. So, or Pj equals to a dot. Then we could just move forward by 1 in both I and j. So dpij, this is going to equal to dpi minus 1, j minus 1. And we can return our result, so return dpij. So this is the case where these 2 characters are the same. So we have another case if the character in P is a wildcard. So remember that it's never possible for a character in S to be a wildcard, so we don't have to worry about this being true. So if Pj equals to a wildcard here, then we need to look at the character prior to the wildcard to see which character we're using 0 or more times. So let's call that prevchar. So this character is the one that we're using 0 or more times. It's going to be pj minus 1. Since j is the index of the wildcard, so j minus 1 is the index of the character that we're actually using. So this is the previous character or character are using 0, oh sorry, not 1 or more times, it's going to be 0 or more times. Okay, so now we have to use this character, so let's remove these 2 indices from j. So if dfs ij minus 2, so basically we can try using this exactly 0 times, so use 0 times. So if this is the case, then we're going to be checking if dfs, this could be true. So if we could use it 0 times, then we're going to use it 0 times. So dpij, this is going to be true, and we want to return true as well. So alternatively, we can use it 1 or more times. So use 1 or more times. So basically splitting the cases into 2 different cases where we use it, the wildcard character 0 or more times or 1 or more times. So if we use it 1 or more times, then we can keep track of index, which is going to be I. And index is going to be representing how many characters or how many times we use this character to remove characters from S. So while index is greater than or equal to 0, so we don't go out of bounds here. And we need to make sure that the character in S is actually equal to the character we're using. So, and S int is equal to prefchar. So if this is true, or prefchar is equal to a dot, which is going to be matching with any character in S. So this bracketed Boolean is going to check for whether or not we can use the current character to remove characters in S. So if any of these are true, then so if DFS in -1, basically removing it up to end, so we're going to DFS for end -1, everything prior to the current range, as well as j-2. We're doing j-2 because we have to remove the wildcard character as well as the character prior to the wildcard character, so j-2. So if this is the case, then dpij is going to be true as well, and we can safely return true. And we're going to continue this while loop while decreasing end. So end minus equals to 1. We got to keep trying until, because we can use the previous character as many times as we want until it no longer matches. So we're going to keep trying to remove one from end until we get a non-matching one. Cool. So after that, we're going to set dpij to false, since if it was true, it would have returned either here or here. So dpij, this is going to be set to false. It is not true that we can get a exact matching from S and P starting with this pair of indices. So if that's the case, we want to return false as well. So how should we call our DFS function? Well, we could just return the DFS function starting from the end. Remember, we're starting from the last index in both strings. So we can do DFS, and we're calling it on m-1 and -1 for the last character index in S and the last index in P. So let's try running that. There's a runtime error. Okay, I had one more bracket here. Let's try running that again. So there's another runtime error for a key error. So dpij is going to equal to dpi-1. Oh, it's going to be dfs i-1 j-1, not dp. So similarly, this should be DFS, because we're not sure this pair has been searched yet, so we're going to call DFS on it. So let's try running that again. Cool, that worked. So let's submit it. Nice. So this question is definitely on the harder end. It's, again, a 2D DP question where we're given two different strings. So in this case, we don't have to build a matrix. Instead, we can use a dictionary as a hash map to store whether or not we can create a perfect matching starting from different indices in S and P. So we also wanted, another trick we did was that we worked backwards, starting from the last index in both strings all the way to the first index, because we want to work backwards, because whenever we have a wildcard character, that means the character prior to the wildcard character has to be the character we're matching. And that's the one we're using 0 or more times. So it just makes our lives a little bit easier to work backwards in this case. So that's it for this question, and that's it for all the 2D DP questions from the LeetCode roadmap. So thank you guys so much for watching. Hope you're able to learn something, and I'll see you in the next video.